Okay, question 37, a proof question with a little bit of a twist, maybe slightly different to some of the proofs you may have seen before. So here's the question then. If you want a clue to how to solve this question and you want to pause the video before you see any more, then the clue is to use the difference of two squares. So factorising 2 to the 4n minus 1 into its two factors using the method of the difference of two squares gives us 2 to the 2n minus 1 times 2 to the 2n plus 1. Now let's have a look at this number 2 to the power 2n. So here are the first few 2 to the 2n's. We start off with 4, and each time we go from one term to the next, we're multiplying by 4 as we go down. And it seems that we've got a pattern emerging here because we've got 4 and then a 6 and then a 4, then a 6. Will this continue forever? Well, the answer is yes, because if a number ends in a 4, then when we multiply that number by 4, then the answer is going to be a number that ends in 6. If we have a number that ends in 6 and we multiply it by 4, the answer is going to be a number that ends in 4. So all of these numbers are going to end in either 4 or 6. So that's the end of the proof required by the question. But interestingly, it can also be proved that 2 to the 4n minus 1 can also be divided by 3. So in fact, 2 to the 4n minus 1, because it can be divided by 5 and 3, can always be divided by 15. But the proof of that, I believe, the best way certainly to prove divisibility by 3 in this case is a thing called proof by induction, and that's the reserve of further maths. There may be a way of doing it without induction, but I haven't been able to find it just now. Anyway, hopefully you managed to get that proof with the little hint if you needed it. If you did, well done.